The electron pair geometry and the molecular shape of XeO2F2 respectively are. We need the knowledge of VSEPR theory to get the answer for these type of questions. First, we will draw the Lewis structure of this molecule. Now we will count the number of valence electrons in this molecule. Xenon is a noble gas and it belongs to the group 18 in the periodic table. Therefore, xenon has 8 valence electrons. Oxygen is a group 16 element. Therefore, one oxygen atom contains 6 valence electrons. But there are 2 oxygen atoms in this molecule. Therefore, the total number of valence electrons in these 2 oxygen atoms is 12. Fluorine is a group 17 element. Therefore, one fluorine atom contains 7 valence electrons. There are 2 fluorine atoms in this molecule. Therefore, the total number of valence electrons in these 2 fluorine atoms is 14. Now we have calculated the total number of valence electrons. This molecule contains 34 valence electrons. These electrons exist as electron pairs. Therefore, we will calculate the number of electron pairs in this molecule. There are 17 electron pairs in this molecule. These electron pairs exist as either bond pairs or lone pairs. The next step is identifying the center atom of this molecule. Usually, the least electronegative element is the center atom of the molecule. This molecule contains xenon, oxygen and fluorine atoms. Xenon is the least electronegative element of these three. Therefore, xenon is the center atom of this molecule. Fluorine always forms single covalent bonds with the center atom. Therefore, we will connect these 2 fluorine atoms to the center atom using 2 single covalent bonds. When oxygen is a terminal atom, it usually forms double covalent bonds with the center atom. Therefore, we can connect these 2 oxygen atoms to the center atom using double covalent bonds. Now we have assigned 6 bond pairs around xenon. Therefore, we can write 6 bond pairs. There are 17 electron pairs in this molecule and we have assigned 6 bond pairs. Therefore, we have to assign 11 lone pairs. Now we will assign these 11 lone pairs around these terminal atoms. We must give octet to the 2 fluorine atoms and these 2 oxygen atoms. First, we will give octet to the highest electronegative element, fluorine. Because of the single covalent bonds, each fluorine atom has 2 electrons. Therefore, we have to assign 3 lone pairs per each fluorine atom. Because of the double bond, each oxygen atom has 4 valence electrons. Therefore, to complete the octet, we need to give 2 lone pairs per each oxygen atom. Now we have assigned 10 lone pairs around these 4 terminal atoms. Therefore, we need to assign the remaining lone pair to the center atom xenon. The final step is assigning formal charge. First, we will calculate the formal charge of a fluorine atom. Formal charge of a fluorine atom equals number of valence electrons 7 minus number of electrons in lone pairs 6 plus number of bond pairs 1. Therefore, formal charge of these 2 fluorine atoms is 0. Now we will calculate the formal charge of these oxygen atoms. Formal charge of an oxygen atom equals number of valence electrons is 6 minus number of electrons in lone pairs 4 plus number of bond pairs. It's 2. Therefore, the formal charge of these 2 oxygen atoms is 0. Finally, we will calculate the formal charge of xenon. Formal charge of xenon equals number of valence electrons 8 minus number of electrons in lone pairs, that is 2, plus number of bond pairs, it's 6. Therefore, the formal charge of xenon is 0. This is a Lewis structure of XeO2F2. Now we will calculate the number of VSEPR units around the center atom. VSEPR units are either single covalent bonds, double covalent bonds, triple covalent bonds, or lone pairs. There are two single covalent bonds, two double covalent bonds, and a lone pair around xenon. Therefore, there are 5 repulsive units or VSEPR units around xenon. If there are 5 repulsive units around a center atom, the electron pair geometry is trigonal bipyramidal. Therefore, we can eliminate third, fourth, and fifth answers. These are the possible shapes of trigonal bipyramidal electron pair geometry. There are 5 atoms connected to the center atom, and the center atom has a lone pair. It is AB4E type. Therefore, the shape of this molecule is seesaw. The answer is number 1.